Okay, so 11.4. And in 11.4, we're going to talk about the slope of a line, ladies and gentlemen. And the slope of a line is basically the measure of how steep a line is in the XY plane. And so this picture here on page 580 will get us started moving in that direction there. Suppose that I graphed a linear equation in the XY plane and it's this red line here. All right, we want to come up with a formula that can actually give us the steepness of this line, or we say the slope of this line. And if I was to walk from this point P sub 1 up to point P sub 2, notice the coordinates of point P1 are x1 comma y1, and the coordinates of point P2 up here are x2 y2. These are supposed to be two unique points on the line. Anyways, if I walk from point P1 up to point P2 along this red line, I will experience two things. I will experience a horizontal change in my location and also a vertical change. We call the horizontal change the amount of run we experience, and we call the vertical change the amount of rise we experience as we walk from one point to another point on this line. Well, as it turns out, ladies and gentlemen, the slope of this line is going to be equal to the ratio of the amount of rise to the amount of run. Okay, so the slope of a line is the vertical change versus the horizontal change we experience as we move from one point on a line to another point. It's called rise over run. To be more specific, how much rise exactly do we experience if we walk from point P1 up to point P2 on this line? Well, the amount of rise we experience is going to be represented by the difference in the y coordinates of these 2 points. And so y2 minus y1, this y coordinate of this point P2 minus the y coordinate of P1 y1, that's the amount of vertical change or the amount of rise we experience as we walk from point P1 up to P2. Okay, the amount of run we experience as we walk from P1 to P2 would be the change in the x coordinates between these 2 points. So that's going to be represented as x sub 2 minus x sub 1. That's the amount of run. So the slope of this red line here is going to be equal to the ratio of the change in y over the change in x, or the amount of rise over the amount of run. And so, ladies and gentlemen, we develop what's called the slope formula right here. So this is an important formula to commit to the memory banks. The slope of a line, and normally they use m to represent the slope of a line. That's the way it is in all the textbooks I've ever seen. So the slope of a line, m, is equal to the rise over the run. Specifically, it's equal to the difference in the y coordinates divided by the difference in the x coordinates as we walk from one point on the line to another point. So that's called the slope formula. And this formula will enable us to compute the slope of a line given 2 unique points on the line. Okay, so any questions about the slope formula and how it was developed? All right, I'm gonna go right down on the problem set here. First batch of problems says, find the slope of the line through the following pairs of points. Then plot each pair of points. Draw a line through them. And indicate the rise and run in the graph in the same manner shown in example 1 and 2. Okay, so I'm going to try problem number 2 here. They give us 2 points on a line, 3, 1, and a 0.54. They want us to compute the slope of this line that contains these 2 points, and then plot them and indicate the slope geometrically. I'm going to call this point 3, 1 my first point, x1, y1, and I'll designate this 0.54 as my second point, x2, y2. Ladies and gentlemen, it does not matter which point you call your first point and your second point. That's totally arbitrary, does not make a difference. You're going to get the same slope either way. So if I use these 2 points here and I want to compute the slope of this line, The slope of the line is m, which is going to be equal to y2 minus y1 divided by x2 minus x1. Rise over run, change in y over change in x. So what's my y2 based on how I labeled these points here? My y2 is going to be 4 minus y1 is going to be 1. And that's going to be over x2 minus x1. x2 is 5 and x1 is 3. So the slope of this line looks like it's going to be 3 over 2. That would be the slope, 3/2. Okay. Let's plot these points in the XY plane. We will assume these tick marks on both X and Y axis are spaced 1 unit apart. So plotting the point 3, 1, we start at the origin. We go 3 to the right, 1, 2, 3, and then up 1. There's 3, 1. Now we're going to plot the point 5, 4, starting at the origin. We go 5 to the right, 1, 2, 3, 4, 5. Now up 4, 1, 2, 3, 4. There is 5, 4. And we discovered that the slope of this line is 3 over 2. Well, geometrically, what does that mean? Well, if we put a line through these points, and suppose I start at this point, and I walk up this point, walk up to this point here, from this point to this point. How much rise would I experience as I walk from this point up to this point? Well, the amount of rise I'm going to experience is going to be 3 positive units, since we're moving in a positive y direction here with the amount of rise. So it'll be 1, 2, 3, plus 3. That's the amount of rise. The amount of run we experience in walking from this point to this point on the line is going to be in the positive x direction, 2 units, plus 2, 1, 2. That's the amount of run. And now you can see why the slope was computed to be 3/2. Everybody see that there? 3 over 2. A rise of 3, a run of 2. I could plot another point on this line if I wanted to, going from this point up 3, 1, 2, 3, and then a run of positive 2, 1, 2. There'd be another point on my line. Any questions how we computed the slope of this line? And we plotted the points, drew the line, and indicated the slope visually by indicating the amount of rise and run we experience as we move from one point to another point on this line. Ladies and gentlemen, it does not matter which point you call your first or second point. For instance, I could have designated 3, 1 as my second point. I could have called it my x2, y2 point, and I could have referred to this point 5, 4 as my first point, x1, y1. The bottom line is it doesn't matter, you'll get the same slope. So suppose that I, labeled my points this way. Now what would be the slope of the line here? Well, it's going to be y2 minus y1 over x2 minus x1. So y2 is going to be 1. Subtract y1 is going to be 4. x2 is going to be 3. x1 is going to be 5. So we would get a slope of -3 over -2. But ladies and gentlemen, I hope you realize that -3 over -2 is the same thing as +3 over +2. These are equivalent to each other. Equivalent. So if you go from one point to another point on this line, if you go up 3 and to the right 2, that'll be equivalent as if you go down 3 and to the left 2. Let me show you. In other words, I could have started at this point and walked down to this point along this line, in which case the amount of rise I would have would be in the negative y direction, 3 units, -3, -1, -2, -3, and then the run would be -2 in the negative x direction. Either way, I will still land on the same line. So whether I go up 3 over to the right 2 or down 3 and to the left 2, I will still be landing on the same line. And that's a result of these being equivalent to each other. So whether you call the slope 3/2 or -3 over -2, it doesn't matter. And it doesn't matter which point you call your first point and your second point. You're going to get the same slope, same line, et cetera, et cetera. Any questions about what's going on here? All right. Okay. So for classwork number one, Liz, I want you to do problem number 6. I want you to compute the slope of this line using a slope formula, and then I want you to plot the points, put a line through the points, and then indicate graphically what the slope is. And it better be equal to what you computed. So number 1, classwork number 1, problem number 6. Now, when you use a slope formula, you got to make sure you're careful with your signs, as sign mistakes are a very common problem. All right, so I'm going to call 2, -5 my first point, 5, 2 my second point. And then I'm going to basically substitute the values into the slope formula to compute the slope of this line that contains these 2 points. So my y2 is going to be 2, subtract y1 being -5, over x2 minus x1. x2 is going to be 5, minus x1 is 2. Hence, it looks like our slope is going to be 2 subtract the -5 is 2 plus 5, which is 7. 5 minus 2 is 3. So the slope of this line looks like it's going to be positive 7/3.
I think it's supposed to be a -3, not a -5, if you're doing number 6.
Hold on, let me double check my points. Supposed to be -3, isn't it? Yeah. So I'm doing some other problem here. All right, so it's going to be -3, and that will change things a little bit here. All right, so this is going to be -3, and so this is going to be 2 minus a -3, which is 2 plus 3 or 5. So slope will be 5/3. Okay. All right, so the slope looks like it's going to be 5/3. Now what I'm going to do is I'm going to plot these points in the XY plane. So I'm going to plot 2, -3. Start at the origin, go 2 to the right, and then down 3, -1, -2, -3. I'm going to plot 5, 2, starting at the origin, go 5 to the right, 1, 2, 3, 4, 5, and then up to 1, 2. Take a ruler, put a line through those points, and you have the graph of that line that contains those 2 points there. Now, to represent the slope geometrically, we're going to pick a point and walk from that point to some other point on the line. And maybe I'll walk from this point up to this point. When I walk from this point up to this point, I experience how much rise? Rise is going to be in the positive y direction, and it's going to be 1, 2, 3, 4, 5. Positive 5 is the rise. And the amount of run is going to be in the negative x direction. That's going to be -1, on the positive x direction, excuse me, +1, +2, +3. And there you can see the slope is definitely 5/3. Okay. Anybody, we get this? Are we getting this here? Okay, so the slope of that line is positive 5/3. All right. So that line has a positive slope. Now I want to draw your attention to something in our textbook here that I'll show you something here. All right. In this diagram here, the graph that's furthest to the left, we call this a falling line, because as you move from left to right on the x-axis, in the xy plane, the points are falling on this red line, and falling lines always have negative slopes. So a line that's oriented this way in the plane will always have a negative slope. That's called a falling line. The horizontal line is a line that always has 0 slope or no slope. This one here is called a rising line. As we move from left to right in the XY plane, we rise on the line, and rising lines always have positive slopes. Finally, vertical lines always have undefined slopes. Okay, undefined slopes for vertical lines. All right, so that's something that you want to be conscious of, so that when you graph your lines, they better have the same orientation as the sign of the slope indicates, or as the slope indicates for the line. Okay. All right. So I just wanted to point that out there. All right. Now let's see here. So let's see if we can find a line in here that has, let's say, like a negative slope to it. All right. We did problem number 6 for classwork number 1. And let's see if we can find a line in here that maybe has a negative slope. Okay, we could try number 10 here. All right, they give us 2 points on the line and they want us to find the slope of this line here. So for number 10, a line goes through the points -3, 3 and the point 3, -1. They want us to compute the slope of this line. So the slope of this line is going to be y2 minus y1 over x2 minus x1. Maybe I'll call this my first point and I'll designate this one as being my second point. In which case we're going to have -1 subtract 3 divided by x sub 2, which is 3, subtract x1, which is -3. So the slope of this line should be -4 over 6. And -4 over 6. That would be the slope of this line here. All right, let's see if we can plot these points and get a visual on this and convince ourselves that we do have a slope of -4, 6. So we plot these 2 points in the XY plane here. So plotting the point -3, 3. 1, 2, -1, -2, -3, and then up 3. 1, 2, 3. There's -3, 3. And then we plot the point 3, -1. Start at the origin, go 3 to the right. 1, 2, 3, and then down 1. There's 3, -1. Put a line through these points, and we can see that this line is not a rising line in the XY plane, but this is a falling line. Okay, and falling lines always have negative slopes, and that's why we got a slope of -4, 6. So if I was to walk from this point on the line down to this point, I would experience what kind of a rise? Well, my rise now would be -1, -2, -3, -4. The rise would be -4, and the run would be +6. So you can see why the slope is -4 over 6. Okay, that's the slope of the line. Now, had we had these 2 points switched here, in other words, if I designated this point as being my second point and 3, -1 being my first point, let's recompute the slope here. y2 minus y1 over x2 minus x1. So now we'll have what? 3 subtract a -1. And that sits over -3 minus 3. So in this case, I would get a slope of 4 over -6. But I have a question for you. Do you think that -4 over 6 is equivalent to 4 over -6? Are these equal? And the answer is yes, they are. If you have a negative fraction, it doesn't matter where you attach the negative sign, you're going to still have the same fraction, whether you attach it to the numerator or the denominator. These are all equivalent to each other. So whether you view this slope as going down 4 units to the right 6 or going up 4 units and to the left 6, doesn't matter. You're talking about the same slope, the same line. So in other words, had I used the slope of being +4 over -6, then that would basically have me walking from this point up to this point on the line, in which case my rise now would be +4. And my run would be -6. +4 over -6. So I hope you realize, ladies and gentlemen, that it's just, it doesn't matter whether you call the slope -4 over +6 or +4 over -6. You're talking about the same line, the same slope. Make sense? Any questions about that? Okay. Suppose that we want to find the slope of the line that contains these 2 points. How about 2, 4 and the point 2, -5? Let's find the slope. We'll call this x1, y1, and we'll call this x2, y2. So the slope of this line is going to be equal to m, which is going to be equal to y2 minus y1 over x2 minus x1, which is going to be -5 subtract 4 over 2 minus 2. In this case, we're going to get -9 divided by 0, and -9 divided by 0, anything divided by 0 is undefined. So this slope is undefined. That's an undefined slope. And what kind of a line has an undefined slope? Wouldn't we like to know? Well, let's plot these points and find out. So let's plot 2, 4, start at the origin, 2 to the right, 1, 2, now up 4, 1, 2, 3, 4, there's 2, 4. And then we're going to plot the point 2, -5, start at the origin, 2 to the right, then down 5, -1, -2, -3, -4, -5. And as it turns out, ladies and gentlemen, this line is going to be a vertical line. And that's why vertical lines have undefined slopes. The reason why they have undefined slopes is because when you move along a vertical line from one point to another, there is no run, only rise. And that's why the denominator of the slope formula is always 0, because there's no run. And that's why vertical lines always have undefined slopes. All right, suppose we want to find the slope of the line that contains these 2 points here, -4, 5, and let's say 6, 5. We'll call this point x1, y1, designate this as x2, y2. Let's compute the slope of this line. So that's going to be 5 minus 5 over 6 minus a -4. Which is going to be 0 over 10, and 0 divided by 10 is 0. So what kind of a line has a 0 slope? Well, let's find out. Let's plot these points and find out. -4, 5 is 4 to the left, -1, 2, 3, 4, now up 5, 1, 2, 3, 4, 5. There's -4, 5, and then we want to plot the point 6, 5. 1, 2, 3, 4, 5, 6, up 5, 1, 2, 3, 4, 5. There's 6, 5. Put a line through these points, and we can see that we have not a vertical line, but we have a horizontal line. And so, ladies and gentlemen, horizontal lines always have 0 slope. Horizontal lines always have zero slope. Makes sense, because when you're on a horizontal line, there is no rise. There's only run as you move from one point to another point. And to say the slope is equal to 0 for a horizontal line means that there's no slope. Meaning that if you're on skis, you're not going to be doing any downhill skiing on a level surface because there's no slope. All right. All right. Any questions how we're computing the slope of a line given 2 points on the line? All right, now they want us to, in this batch of problems, they want us to graph the line with the given slope and the y-intercept. So they're going to give us 2 key pieces of information about a line, its slope and its y-intercept. And they want us to, using that information, graph the line. Okay. Notice they're calling the y-intercept B, and you'll see why it's called B when we get into the later sections here this afternoon. All right, so let's try one out here. Let's try out problem number 16. They indicate to us that the y-intercept of this line is to be equal to -2. And they indicate the slope of the line is 3/4. All right, so knowing the y-intercept is -2 and the slope is 3/4, let's see if we can graph this line. First, we'll plot the y-intercept, which is -2, which is -1, -2. There's the y-intercept. 0, -2. And then they want us to they want us to graph this line, knowing the y-intercept is at 0, -2, and knowing the slope is 3/4. Well, we know that slope is rise over run. Meaning that if I start at my y-intercept, if I go up 3 units, I would have to go over to the right 4 units to land on the same line. So let's do that. Let's start at the y-intercept and go up 3 units. 1, 2, 3. There's a rise of 3. Now a run of +4. 4 to the right. +1, 2, 3, 4. We have a rise of 3 and a run of 4. Therefore, we must have another point on our line right here. We could do that again. Up 3. 1, 2, 3. And a run of 4. 1, 2, 3, 4. And there better be another point on our line right here. Or I could have viewed my slope as being -3 over -4, which means I go down 3 and to the left 4. So I could have, for my y-intercept, gone down 3 units, -1, -2, -3 for the rise, and then -4, -1, -2, -3, -4 for the run. There should be another point on my line right there. Take a ruler and let's put a line through these points, and lo and behold, we have the graph of that equation. And that's the graph. So whether you view the slope as being 3/4 or -3 over -4, doesn't matter. It's the same slope, same line, same steepness. Notice this is a positive slope for this line because it's a rising line in the XY plane. Notice we get kind of like a stair feature when we show the slope. And therefore, it's no small wonder that stairs have slope to them also. They have so much rise versus so much run. Okay. All right. Any questions how using the y-intercept and the slope of that line, we're able to graph that line? That's how you're going to do all those problems right there. All right, now in problems 27 through 30, they give us the graph of a linear equation, and they want us to find the slope and the y-intercept for these lines. I will do problem number 28. How can we determine the y-intercept of that line? Well, it's pretty simple, because where does the line go through the y-axis at? So the line goes through the y-axis at 4, so the y-intercept would be equal to 4, or as an ordered pair, the y-intercept would be the 0.04. But to compute the slope of this line, we could do it one of two ways. We could choose another point on our line, like the 0.20, which happens to be an x-intercept. And using 20 and 0.4, we could then compute the slope of this line. Or you could do it another way. You could start at 0.4 and then walk down to 0.20, realizing that your rise then would be -1, -2, -3, -4, and your run would be +1, +2. So it looks like if you walk from 0.4 down to 20, you're going to have a rise of -4 and a run of +2. So it looks like your slope of this line would be -4/2. -4/2 would be the slope. Or you could choose 2 points on the line. Like I said, you could use the y-intercept as your first point and this x-intercept 20 as your second point. And then you could put them into the slope formula and crank out your slope that way. So the slope of this line is going to be y2 minus y1 over x2 minus x1, which is to say 0 subtract 4 over 2 minus 0, which is negative 4 halves. So that would be the slope of this line, negative 4 halves. Okay. And the y-intercept is 4. Questions on that problem? All right. I want to go down here and apply this slope concept to a problem here. Here's a graph of number 54 that gives us the heating of a block of ice. So ladies and gentlemen, if you were to heat up a block of ice, what's going to happen is, first of all, the ice temperature has to be raised to the freezing temperature of water, which is 0 degrees Celsius. And then when you can keep applying heat to the ice that's now at 0 degrees Celsius, a phase change occurs where your ice becomes a liquid. So we experience a phase change between a solid and a liquid at a constant temperature. And then once the liquid, the ice melts completely into water, then, and only after then, can the water temperature then begin to rise as we continue to apply more heat. So the water temperature then rises, and then it rises eventually to 100 degrees Celsius, in which case then evaporation will occur, where the water changes phase again from a liquid to a gas. And that occurs at a constant temperature. Okay, so this graph here indicates the temperature for the vertical axis versus the amount of time it takes to experience all these different phases of liquid and solid, liquid, and gas. All right, it says for question A here, how long does it take all the ice to melt? Well, all the ice melts, ladies and gentlemen, from time t equals 0, when it initially is a block of ice at minus 20 degrees Celsius. And then when you start applying heat to this block of ice at minus 20 Celsius, it starts to warm up to the melting point of ice, or the freezing point of water is 0 degrees Celsius. And then the ice starts to melt, and it continues to melt from, it looks like, about 2 minutes, time 2 minutes, all the way up to time 10 minutes. And then the ice is completely melted after 10 minutes. So it takes 10 minutes for all the ice to melt. And it says, from the time that the heat is applied to the block of ice, how long is it before the water boils? Well, notice we start applying heat to this block of ice at time t equals 0, and the water starts to boil after 20 minutes. After 20 minutes, the water begins to undergo a phase change from liquid to gas. That means it starts to boil or evaporate. So it takes 20 minutes from the time we start applying heat to the block of ice to the time when the water starts to boil. Find the slope of the line segment labeled A. So what would be the slope of this line segment A here? No, that's going to be difficult to determine because we don't know what this x-intercept is up here. That may be a great question. Let's find the slope of the line segment labeled C. To do that, we need 2 points on this line, and we do have 2 points. This point down here is 10, 0. 10 minutes later, the water temperature is at 0 degrees Celsius. To 20 minutes later, the water temperature is warmed up to 100 degrees Celsius. So we have two ordered pairs we can use to compute the slope of line segment C. We have the point 10, 0, and we have the point 20, 100. Everybody see that there? We got 2 points. This point I'll call x1, y1, and I'll designate this as being my x2, y2 point. So therefore, the slope of line segment C here is going to be equal to y2 minus y1 over x2 minus x1. which is going to be based on how I label my points, 100 minus 0 divided by 20 minus 10. So therefore, the slope of line segment C is going to be 100 over 20. Wrong. What's 20 take away 10? Not 20. So this will be 100 over 10, and then that reduces down to 10 over 1. How do we interpret what this is saying? Well, it's saying the water is warming up at a rate of 10 degrees Celsius per every 1 minute. So the rate with which the water is warming up as we continue to apply heat is 10 degrees per minute. That's the rate with which the water is warming up between 10 minutes and 20 minutes. That's the slope of this line segment C. So slope is a rate of change. In this case, it's the rate of change of temperature versus time. The rate of change of temperature versus versus the change in time. So the water is warming up between 10 minutes and 20 minutes at a rate of 10 degrees Celsius per every minute. Any questions about this section here? All right, let's move on. Section 11.5 is entitled Finding the Equation of a Line. Okay, so now we're going to learn how to write equations of lines in section 10.5. And to do that, a good place to start is trying to understand the different forms for a linear equation here. So 11.5, writing equations of lines. Well, when a linear equation is in this form here, we say that the linear equation is in standard form. If you solve this linear equation for y and get it into this form, y equals mx plus b form, we say this equation is in slope-intercept form. They call it slope-intercept form because you can literally read off the slope from the equation. M is the slope of the line. B is the y-intercept of the line. That's why they call this slope-intercept form for a linear equation. And there's one more form for a linear equation. It's y minus y1 is equal to your slope m times x minus x1. This is called point slope form for a linear equation. Point slope form. They call it point slope form because from the equation, you can read off a point that lies on the line, namely x sub 1, y sub 1. That's a point that the line contains, or the line passes through. Or we say this point lies on the graph of our linear equation. Point, there's a point, and slope. The slope is m again. So m is equal to the slope. So you can read off all that information from this equation. You can read off a point that lies on the line, this point, and you can also read off the slope of this line. By the way, the slope in point slope form is the same as the slope in slope-intercept form. These are the same numbers. So those are the three different forms for a linear equation. The most popular is slope-intercept form right here. This is the form that's used most often. All right, ladies and gentlemen, using those forms, we can begin to address the issue in this section, which is learning how to write the equation of a line. So let's just go down to our exercise set and begin. All right, so problems 1 through 8, it says in each of the following problems, give the equation of the line with the given slope and y-intercept. Well, for problem number 2 here, they indicate the slope of a line is positive 3/4, and they indicate the y-intercept of the line, which they call b, is equal to -2. Armed with that knowledge, they want us now to write the equation of this line. So do we have enough information to write the equation of this line? What do you think? Yes or no? Anybody? We got enough information to write the equation of that line knowing its slope and y-intercept? So using the slope intercept form y equals mx plus b, we can now write the equation of this line just by substituting in what for m? What's the slope of this line? 3/4 plus what's the y-intercept? -2. And ladies and gentlemen, we're done with this problem. We have the equation of this line. It's y equal to 3/4 x minus 2. And this equation is written in what form? Standard slope intercept form or point slope form? What form? That's slope intercept form. All right. By the way, the slope is a positive slope. So if we were to take the time and graph this line in the XY plane, we would expect it to be a rising line. It would have to be oriented this way. Rising lines have positive slopes. And the line would have to go through the y-axis at -2, because that's its y-intercept, -2. So that's where the line would have to go through the y-axis at. Questions how we wrote the equation of that line? That's what you're going to do with every one of these. They're all repeats. They give you the slope and the y-intercept. You should be able to write the equation of the line and leave your answer in slope-intercept form. Anybody want to see another one of those done? All right. Next batch of problems says find the slope and the y-intercept for each of the following equations by writing them in the form of y equals mx plus b, then graph each equation. Notice these equations, these linear equations, are not in slope-intercept form. They are in standard form, ax plus by equals c form. They are in standard form. So in order to ascertain the slope and the y-intercept, what we're going to have to do is take it upon ourselves to solve these equations, first of all, for y, to put them into slope-intercept form. We will probably try problem number 10 here. So for problem number 10, this equation is in standard form. It's in the form of ax plus by equals c form. We call that standard form. Ladies and gentlemen, they want us to get this in the slope-intercept form. So we solve for y to put the equation into y equals mx plus b form. And that form is called slope-intercept form. So to solve this equation for y, we got to get y all by itself. And how do we do that? Well, how do we move the minus 2x over to the right side of our equation? We add 2x to both sides. 2x's drop on the left, leaving us with y all by itself. And I'm going to spin these terms around. And ladies and gentlemen, we have accomplished our task. This equation now is in slope-intercept form, y equal to mx plus b form. Therefore, since that's the case, the slope of my line should be 2, or 2 over 1. The y-intercept, we can read it right off from the equation. The y-intercept is equal to positive 2. This is your y-intercept. Or you could cite it as an ordered pair, namely 0, 2. Questions how we got this equation from standard form in the slope-intercept form, and then we read off the slope of the line as being 2 and the y-intercept as being 2. Ladies and gentlemen, knowing this information, we can graph this equation now very, very easily. Not difficult to do, especially if you have a piece of graphing paper. All right, so let's see if we can do this. Well, we know that the y-intercept is 2, so there's the y-intercept at 0, 2 there. And we know that the slope is 2 over 1, so that's a rise of 2 and a run of 1. So I could start at my y-intercept and go up 2, a rise of 2, 1, 2, and then a run of 1, positive 1. So up 2, a run of positive 1. There should be another point on your line. We could do that again, a rise of 2, up 2 over 1 to the right, up 2 over 1 to the right, up 2 over 1 to the right. You can do this to the end of time. Another way to think of your slope is instead of being 2 over 1, you could think of it as being negative 2 over negative 1. Same thing. So I could have went from my y-intercept down 2 units and 1 unit to the left. Y-intercept down 2 units, negative 1, negative 2, and then 1 to the left. Another point on our line. Down 2, negative 1, negative 2, 1 to the left, another point on our line. Down 2, 1 to the left, another point on our line. I think we have more than enough points to graph this line. Take a ruler, put a line through your points, and you have the graph of that linear equation, y equals 2x plus 2. So the graph of y equals 2x plus 2 is this line right here, whose y-intercept is right there, which is 0, 2, and whose slope is 2 over 1. Questions, ladies and gentlemen, how we did that problem? How we first got the equation from standard form to slope-intercept form by solving it for y. How we read off the slope and the y-intercept, and then made use of that information then to graph the linear equation. All righty, any questions about that? All right, let's move on then. All these other problems are going to be pretty much the same song and dance. Maybe I could just demonstrate at least one more here. Number 18. Okay, here they give you problem number 18. They give you a linear equation, negative 4x plus 5y is equal to 20, and this linear equation is in standard form, ax plus by form, and they want us to, first of all, put it in the slope-intercept form by solving the equation for y. So how do we do that? How do we solve for y? Well, let's move this negative 4x over to the right by adding 4x to both sides. Got to add 4x to the right side also. These 4x's drop out on the left, leaving you with 5y, and that's equal to 20 plus 4x, or I'm going to spin it around and call it 4x plus 20. Dividing both sides by 5 to solve for y means I got to divide both terms on the right side of my equation by 5. Now I'll have my equation looking like y is equal to 4x divided by 5 is the same thing as 4/5 times x. 20 divided by 5 reduces down to 4. And we're done. Ladies and gentlemen, this equation now is in what form? It's in slope-intercept form. Being in slope-intercept form, I should be able to read off the slope of this line. And the slope of my line is m, which is equal to what? 4/5. That's the slope of the line. The y-intercept is positive 4. That's that number b. Or as an ordered pair, it would be 0, 4. Now, knowing this information, we should be able to graph this linear equation, knowing its slope and its y-intercept. So how do we do that? How do we graph this equation now? Well, we're going to go to a graphing paper, and we're going to plot the y-intercept. And then we're going to plot other points in the line by acknowledging the fact that our slope is a rise of 4 and a run of positive 5. So let's take a piece of graphing paper here. Let's plot our y-intercept, which is 4. There's your y-intercept, 0, 4. And now we know the slope is 4/5. So if I start at my y-intercept and go up 4, 1, 2, 3, 4, up 4, then I would have a run of 5. 1, 2, 3, 4, 5. So up 4/5. There should be another point on our line right there. So up 4/5. Or I could have viewed my slope as being -4/-5, which means I go down 4 and to the left 5. I could have just as well started my y-intercept and went down 4, -1, -2, -3, -4, and then 5 to the left. -1, -2, -3, -4, -5. There's another point on my line. Take a ruler, put a line through these points, and you have the graph of that linear equation. It's that simple. Make sure you put arrows at the end of the line. And there you go, ladies and gentlemen. That would be the graph of the equation y = 4/5 x + 4. Any questions how we're putting a linear equation from standard form into slope-intercept form by solving the equation for y, then reading off the slope, reading off the y-intercept, and using that information then to graph our linear equation? Any questions, ladies and gentlemen, with what's going on here? Okay. All right, now the next block of problems here says, for each of the following problems, the slope and a 1 point on a line are given to us. In each case, they want us to use the point slope form to find the equation of the line, and they want us to write our final answer in slope intercept form. How are we going to do one of these problems? Well, very carefully. We'll try problem 22. In problem 22, they give us two pieces of information about a line. They give us a point that lies on the line, -1, -5, and they indicate the slope of the line is to be +2. Using that information, they want us to write the equation of this line. So, ladies and gentlemen, they give us a point that lies on our line. I'll call it point x1, y1. They give us the slope of the line. And we are going to use what is called the point slope form to derive the equation of this line. And what is the point slope form for a linear equation? That's going to be y minus y1 is equal to your slope m times x minus x1. That's called point slope form for a linear equation. To write the equation of this line that contains this point and has this slope is pretty easy now. All I do is replace the y1 variable in this equation with the y coordinate of this point. So -5 drops in for y1. Equals the slope they told us is 2. That drops in for m. And x1 takes on the value of -1. And ladies and gentlemen, we have the equation of our line right here in point slope form. Everybody see what just happened there? Y subtract a -5 is really y plus 5. X subtract a -1 is really x plus 1. But they want our final answer to be put in slope intercept form, which means we have to solve this equation for y to get this equation into y equals mx plus b form. To do that, I'm going to distribute the 2 inside the parentheses on the right side of my equation. And now I'm going to solve for y by subtracting 5 from both sides of my equation. Hence, y is equal to 2x, and 2 minus 5 is -3. Ladies and gentlemen, we're done. We have our equation written in slope intercept form. We're done with that problem. And you can clearly see that being in slope intercept form, y equals mx plus b form, you can see that the slope of this line is 2, and that's exactly what they told us it was, 2, and the y-intercept is going to be -3. This is not a y-intercept, this point, because this point does not lie on the y-axis, so it's not a y-intercept. The y-intercept would be -3. Any questions how we did that problem there? Number 22. That's how you're going to do the rest of these problems, same way. Let's see. Maybe we should try another one. I'll try number, I'll do number 26 here. All right, problem 26. They give us a point that lies on the line, and they give us that slope is 4/3. And what we need to do is we need to write the equation of this line. So we have to write the equation of this line. To do that, we'll call this point x1, y1, and we know our slope. We will use the point slope form to get us started here. And that's y minus y1 is equal to your slope m times x minus x1. So we make our substitutions. In for y1, I'm going to substitute -4. Our slope m is told to be 4/3. In for x of 1, I'm going to substitute in 3. And there's your equation. Now they want our final answer to be in slope intercept form. So we have a little simplifying to do here. So y minus a -4 is y plus 4. And this is 4/3 and x minus 3 right here. Now we got to solve this equation for y. To move in that direction, first I'm going to distribute the 4/3 inside the parentheses, in which case I got y plus 4 is equal to 4/3 times x is 4/3 x. And 4/3 times a -3. So I got y plus 4 is equal to 4/3 x. And 4/3 times -3 is going to be -12/3, which these 3's cross cancel. Another way of looking at it, and you'd have like -4 here. So what do you want to call this? -12/3, which is down, reduces down to -4, or cross cancel out to 3's, you're going to get -4. Finally, we add 4 to both sides, subtract 4 from both sides of the equation to solve for y. So therefore, we got y all by itself, and y is equal to 4/3 x. -4 minus 4 is -8. And we're done, ladies and gentlemen. This is called slope intercept form. This is the form y equal to mx plus b. So we can see that the slope of this line is 4/3 right here. And that's what they indicated it was up here. And they indicated the y-intercept is -8 here. So the line would go through the y-axis at -8 and has a positive slope. So it would be a rising line if you were to graph it, since it has a positive slope. Any questions? How we did that problem there? Number 26. All right, one like number 30. They give us a line contains this point -5, 2, and its slope is to be equal to 0. They want us to write the equation of this line. So given that this point is contained by the line, or the line passes through this point and has a slope of 0, well, for one thing, ladies and gentlemen, we know that any line that has a slope of 0 has to be a horizontal line. Horizontal line. Which means the equation of a horizontal line is just going to be y equal to the y coordinate of the point that the line contains. So y is equal to 2 right here. And we're done. That's your equation of your line. Y equals 2 is the equation of a horizontal line that contains this point and has a slope of 0. That's your answer. All right, number 32, they tell us a line contains a point -5, 1, and now the slope is undefined. Well, what kind of lines have undefined slopes? Well, the only lines that have undefined slopes are vertical lines. And the equation, so this is going to be a vertical line. And the equation of a vertical line is always x equal to the x coordinate of a point that sits on the line. So x is equal to -5. There's your answer. This is the equation of a vertical line that contains this point and has the undefined slope. All right, on this next batch of problems, they're going to give us a line that contains 2 points, and they want us to write the equation of our line. And they want our answer to be in slope-intercept form. You know, for all the other problems I did above that used point-slope form, another way, Liz, you could write the equation of the line is you don't have to use point-slope form. You could just as well use slope-intercept form to write the equation of the line. I'm going to demonstrate that with this batch of problems. Although, if you still insist on using the point slope form for this batch of problems, you could still do that. But this batch of problems, I'm going to demonstrate another way to write the equation of these lines by using the slope intercept form. All right, so let's pick a problem here. Problem number 34. In 34, they give us 2 points that a line contains, 2, 4, and the other point is -3, -1. And knowing that the line contains those 2 points, they want us to write the equation of this line. Well, the first thing we need to know is we got to find the slope. So I'm going to call this point my first point and designate this as being my x2, y2 point. So therefore, what would be the slope of the line? It's going to be y2 minus y1 over x2 minus x1. Our y2 is -1, subtract y1 is 4. x2 is -3, subtract x1, which is 2. So the slope of this line is going to be -5 over -5, which is going to be +1. So that would be the slope of this line is 1, or 1 over 1. Now we know the slope of our line is 1. And I'm going to choose a point now. It does not matter which point you choose, the first or the second one. You're going to get the same equation regardless. I'm going to choose the first point, which is 2, 4. And I'm going to call that my point generically xy. This time, instead of using point slope form, I'm going to use slope intercept form to write the equation of this line. I'm going to use this slope intercept form. Now, if this point satisfies, or excuse me, if this point lies on the graph of our linear equation, then it has to satisfy this linear equation, meaning that I should be able to substitute in for my x variable, the x coordinate of this point. I should be able to substitute in for the y variable in this equation, the y coordinate of this point. And the slope takes on the value of 1. That's what we computed for the slope. So 1 drops in right here. All right, so let's start to write our equation of our line. So y takes on the value of 4, our slope m is 1, and x takes on the value of the x coordinate of the point we chose. And now we have to solve this equation for the y-intercept b. So how do we solve for b? Well, we subtract 2 from both sides. And therefore, it looks like the y-intercept is 2. So here's our equation, ladies and gentlemen, in slope-intercept form. Our equation of our line has to be y equal to m. Our slope m is 1 times x plus b. We found b, our y-intercept, to be 2. There's your answer. That's the equation of the line that contains these 2 points. It's y equal to x plus 2. Any questions how I derived the equation for that line there? First, I found the slope. I chose one of my 2 points using slope-intercept form. I made my substitutions, solved for the y-intercept, and then I wrote my equation. Any questions about that? All right, that's one like number 34 there. Okay. Maybe I could try another one here. All right, I'll try one more like that, like number 40 here, because we are fighting the clock here. And we're losing the battle. All right, number 40. All right, now in number 40, they give us 2 points that lie on a line, and they want us to write the equation of this line here. To do that, we have to first find the slope of the line. So I'm going to call this my first point, this is my second point. Hence, I'm going to use my slope formula now to crank out the slope of this line. Y sub 2 takes on the value of 1 minus y sub 1 takes on the value of -5 over x sub 2 takes on the value of 3 minus x sub 1 takes on the value of -3. Just be careful of your signs when working with the slope formula. 1 subtract the -5 is 1 plus 5, which is 6. 3 subtract the -3 is 3 plus 3 is 6. We get a slope of 1 again. Interesting. Now, what I'm going to do is I'm going to choose a point. It does not matter what point you choose. I'm going to go with -3, -5. I will generically call that my point xy. And now I'm going to use my slope-intercept form to write the equation of this line. All right, so what drops in for the y variable? Y is -5. My slope m was computed to be 1 times x. The x variable is replaced with the x coordinate, which is -3. And now we can solve this equation for the y-intercept. Add 3 to both sides. We now get -2 is equal to your y-intercept. And ladies and gentlemen, now that we found our y-intercept is -2, we can write the equation of our line. So our equation is simply going to be y equal to mx plus b. M is the slope of 1, x plus b, b is -2. We found that back over here. You got the equation of your line. Y equals mx plus b. M is your slope, 1, b is your y-intercept, -2, and we're done. Any questions how we wrote the equation of that line? Now they're going to give us a graph of a line in the XY plane, and they want us using the graph to write the equation of the line. They want the final answer to be in slope-intercept form. So I have a question for you. Problem number 46. First, we need to determine the slope of the line. How can we determine that? Well, you can do one of two ways. You can do it graphically or use the slope formula. It's up to you. If we do it graphically, if I walk from 0.05 down the line to 0.30, I would have a rise of -1, -2, -3, -4, -5 would be the rise. And the run would be +1, +2, +3. So it looks like the slope of this line would be -5 over 3. Or you could use these 2 points, 0.5 and 3.0, and put them into the slope formula. You get the same slope of -5/3. Notice this is a falling line, and therefore it's no surprise that the slope is negative. -5/3 would be the slope. So as we now know the slope is -5/3, are we lucky enough to be able to read off the y-intercept of this line? You betcha. The y-intercept is 0.5, or the y-intercept is 5. Hence, we know the slope is -5/3, and we know the y-intercept is 5. We can easily write the equation of this line now, just by using the slope-intercept form. So 5 drops in for the y-intercept. M takes on the value of -5/3. Therefore, the equation of this line is going to be y equal to -5/3 x plus 5, and we're done. And that's your answer. That would be the equation of that line that is graphed. That is graphed in problem number 46. Any questions how we determine that? All these problems are going to be easy because they give you the y-intercept. You can literally read the y-intercept off of each line. So they're done equally easily. All right, any questions, ladies and gentlemen, how we did that problem there? Any one of those problems there? All right. The only, let's see, I think we're good on that. And then I made a note that I wanted to do problem like number 64 down here. What's that one? Okay. Let's try to do this application problem here. It says Elliot buys a new forklift for his business. It will cost $140,000 and will decrease in value each year. In other words, let's to say that the value of this forklift is going to decrease each year means that its value, ladies and gentlemen, will depreciate every year. And that's usually what happens when you buy something new. Like you buy a brand new car, its value depreciates every single year. In fact, I am told that when you drive a brand new car off the lot, it loses $5,000 worth of value just by driving it off the lot, the car lot. Anyways, the graph below shows the value of the forklift after the first 6 years of ownership. Notice the horizontal axis is the time in years and the vertical axis is the value of the forklift. Notice at time t equals 0, ladies and gentlemen, that's when the forklift was just purchased. That's going to be the y-intercept up here, which is $140,000. So the value of the brand new forklift is represented by the y-intercept of this graph, which is to say that the value when the forklift was new was $140,000. Notice the value of this forklift steadily falls or decreases versus time. So after 6 years of ownership, the value of this forklift has lost $120,000 worth of value. It's all the way down to a value of a pithy $20,000. So you can see how the depreciation of the value of this forklift is represented by the graph of this line here. Question A, it says, how much is the forklift worth after 6 years? Well, it's only worth $20,000. Question B, after how many years is the forklift worth $80,000? Well, $80,000, project it over to, you hit the red line, and you can see that that would occur 3 years after ownership. So 3 years after this forklift is purchased, its value will have decreased to a value of $80,000. Find the slope of this line. Well, to find the slope of this line, ladies and gentlemen, we need to have 2 points on the line, or we could do it geometrically by walking from one point to some other point on the line. We could observe the amount of rise versus the amount of run we experience. For instance, if I walk from this point, the y-intercept up here, 0, 140,000, all the way down to this point in the lower right corner, which is 6, 20,000, how much rise would I experience? Well, the value decreases by what? How many thousand? Notice these tick marks on the vertical or y-axis are spaced $20,000 apart. So that means if I walk from this point here down to the lower right corner point of this red line, the rise will be a negative 20, 40, 60, 80, 100, 120. So the rise will be negative $120,000 versus the run will be positive 1, positive 2, positive 3, positive 4, positive 5, positive 6. So the slope of this line will be negative 120,000 divided by 6. So the slope of that line, ladies and gentlemen, is going to be equal to negative $120,000 per every 6 years. That's the slope of the line. That represents the rate at which this forklift is losing value. It's losing value at a rate of $120,000 per 6 years, or if you reduce that slope down, it's losing a value of $20,000 per every 1 year. That's the rate with which it's depreciating. Slope is a rate of change. In this case, it's the rate of change of value versus time. All right, that's the slope of that red line. All right, D, how many dollars per year is the forklift decreasing in value? Well, we've already indicated that every year it's losing $20,000 worth of value every year, because that's what the slope is telling us. All right, for the last question here, it says, find the equation of this line where V is equal to the value after T years. Well, ladies and gentlemen, we know the slope is negative 20,000 over 1, or negative 120,000 over 6. Knowing the slope, I'll use the unit slope, which is to say that the slope is negative 220,000 over 1. And we can use the y-intercept, the fact that the y-intercept is 140,000 up there. So knowing the slope is this, and knowing the y-intercept is 140,000, this is dollars. we can write the equation of this line. So the value of this forklift, V, is equal to mx plus b. The slope is negative 20,000. Now they're not using x for time, they're using t. Plus the y-intercept b is 140,000. You have the equation of that red line, ladies and gentlemen. That's its equation. This is the slope. That's the y-intercept. Slope is negative, and that's why that value line is falling, because the forklift is losing value versus time, not gaining value. That makes sense how I wrote the equation of that line. All right, just one more section here. That's 11.6. And 11.6 is going to have us graphing linear equations in two variables. All right. And the way to get started on this, ladies and gentlemen, is just to jump down and just dive into some problems. So I'm going to illustrate several of these. Notice these are not equations in X and Y. These are inequalities in X and Y. No longer do we have the equal signs. We have the less than, or the greater than or equal to, or the less than or equal to, okay, or the greater than. So these are called, in this section here, 11.6, these are called linear inequalities in two variables. And this first one I'm going to put under the microscope is problem number 2 here. We're going to try to solve this linear inequality for all of its ordered pair solutions. And so, ladies and gentlemen, the solution to this linear inequality in X and Y is going to be an ordered pair. So solutions are ordered pairs that satisfy the equation. Excuse me, satisfy the inequality. All right, so there's going to be an infinite number of solutions to this inequality. There's an infinite number of ordered pairs, such that when you replace the x variable with the x coordinate, y variable with the y coordinate, you're going to get a true statement. Let's see if we can just think of maybe one ordered pair solution to this thing, just one of them. Well, is 10, 0 a solution to this linear inequality in X and Y? Well, to find out, you replace the x variable with the x coordinate and the y variable with the y coordinate, and then verify. Is 3 times 10 plus 2 times 0 greater than or equal to 6? Is 30 plus 0 greater than or equal to 6? The answer is yes. So I have found one ordered pair solution to that inequality in X and Y. It's 10, 0. But ladies and gentlemen, trust you me when I say this, this has not one ordered pair solution, but it has an infinite number of them. So there's no way I'm going to sit here and enumerate all the infinite solutions of this thing, because if I did, I would be here till the end of time or death, whatever grabs me first.
I think that that problem is wrong, because it's supposed to be less than.
Let me see. Problem number 2?
No, never mind. You said number 2. Never mind.
Let me see.
I was looking number 1. Never mind.
Now I'm doing number 2 here.
Yes.
All right. So there's no way I'm going to sit here and enumerate all the ordered pair solutions. There's too many. So how do we represent the infinite number of ordered pair solutions to this inequality? Well, we really don't, not directly. What we do is we graph the solution set. So we're going to graph 3x plus 2y greater than or equal to 6, because when we graph it, that will indicate all the ordered pair solutions to such an inequality. Well, how do we do that? Well, first of all, we must graph the associated equation. We have to graph 3x plus 2y equals 6. The reason why we have to graph the equation first is because we got to know where the boundary is that separates the plane that contains solutions versus the plane that does not contain solutions in the XY plane. And so, ladies and gentlemen, how do we graph this linear equation in X and Y? Well, there's many ways. We could use the table method. We could put this in the slope-intercept form. Using the slope and the y-intercept, we could graph it. Or we could find the X and Y intercepts of this thing and graph it. You know, I love finding X and Y intercepts because I'm always setting something equal to 0. And so, you know what, to graph this linear equation, I'm going to find its X and Y intercepts and use those points to do so. So how do you find an X intercept? You always set Y equal to 0. Take 0, substitute it in for the Y variable. And now we can solve this equation for X because this is going to drop out. So we're left with 3X equals 6, divide both sides by 3. And that implies that my X-intercept is 2 or 2, 0, therefore must be 1 point that lies on the graph of this line here. To find the Y-intercept, we set X equal to 0. Take 0, substitute in for the X variable into the equation. And then we'll just solve the equation for Y as this drops out. Hence, it looks like the Y-intercept is going to be 3. There's your Y-intercept. Now that we know our X-intercept and our Y-intercept, that should be enough information to graph this equation or this line here. So we're going to take a piece of graphing paper. We're going to plot the X and Y intercepts and put a line through them, and then we'll have the graph of this linear equation. So I'm going to plot 2, 0. There's 2, 0. And then I'm going to, this is my X-axis, here's my Y-axis, and I'm going to plot the ordered pairs 0, 3, the Y-intercept. 0, 3 is going to be starting at the origin. We go up 3 on the Y-axis, 0, 0, 3. Now, this is something that we need to understand. Ladies and gentlemen, if you ever have the equal sign as part of your inequality, you are always to use a solid line. If you have the strict inequality of strictly less than or strictly greater than, you always use a dashed line. Notice my inequality has greater than or equal to, which means since I got the equal sign as part of my inequality, I use a solid line. So I'm going to put a solid line through these points here, these intercepts. So I'll take a ruler, put a solid line through, and ladies and gentlemen, we have the graph of that boundary there. Now we need to determine whether we shade below and to the left to denote solutions to this inequality, or we shade above and to the right to denote ordered pair solutions to this inequality. How do we know which way we shade? Well, we're going to have to choose a convenient test point. And the easiest test point you can always choose is the origin, which is 0, 0. The only time you cannot choose 0, 0 is if your line actually goes through 0, 0. Then you have to choose some other point. But 0, 0 is available here. So what I'm going to do is I am going to test 0, 0 in my inequality, and my inequality is 3x plus 2y is greater than or equal to 6. I want to see if 0, 0 is a solution to this inequality. To determine that, I replace the x variable with the x coordinate of 0, the y variable with the y coordinate of 0, and we verify. Is 3 times 0 plus 2 times 0, is that greater than or equal to 6? Is that true or false? Is 0 greater than or equal to 6? True or false? That's false. And therefore, we have discovered that 0, 0 is not a solution to the inequality 3x plus 2y greater than or equal to 6. And since 0, 0 is not a solution to this inequality, we shade the plane that does not contain 0, 0. Now, if 0, 0 was found to be a solution to this inequality, we would shade the plane that contains 0, 0. But 0, 0 is not found to be a solution in our inequality. And therefore, ladies and gentlemen, how do we shade? Do I shade the plane below and to the left, or the plane above and to the right? What do you think? Remember, my shaded region cannot contain 0, 0. It's not a solution to my inequality. So what plane would I have to shade then? Well, the only plane I can shade to exclude 0, 0 would be the the plane above and to the right. So you're looking at the graph of the solution set to this inequality. Any ordered pair or point that lies on either on this boundary, this line, or lies in the shaded region would be a solution to this linear inequality in X and Y. And you can see there's an infinite number of points that lie in a shaded region or on this line. And that's why this inequality has an infinite number of ordered pair solutions. Any questions how we graph the solution set of that inequality? And of course, this line goes on forever, correct, in both directions. So, any questions on how we graphed it? All right, maybe we can try another one. All right. I'm going to try one like number 8 here. All right, number 8, we have 4x plus 3y is less than 12. And we want to graph the solutions for this inequality, okay? So that's what we want to do. We want to graph the solutions for this inequality. So to do that, first we have to graph the associated equation. Got to graph this line first. Best way to do that, although you could do it many ways. You could use the table method, start generating the ordered pair solutions. You could put this in the slope-intercept form, y equals mx plus b form, and graph it from that. Or, ladies and gentlemen, we could just find the x and y intercepts. I'm going to find the x and y intercepts. They're the easiest way to go here because I'm always setting something equal to 0. So to find the x-intercept, I let y be 0. Take 0, plug it in for the y variable into the equation, and then we'll have to solve for x. Therefore, we get 4x equals 12. Solving for x, dividing both sides by 4, we get 3. So the x-intercept is the point is 3, 0. That's where the graph of this line is going to go through the x-axis at. To find the y-intercept, we let x be 0. Take 0, substitute it in for the x variable into the linear equation, and then we solve for y. That's gone. So we got 3y is equal to 12. Divide both sides by 3, and we get y is equal to 4. Hence, my y-intercept is 0, 4. Now that I know the x-intercept and the y-intercept, and they're 2 unique points, that should be more than enough to graph this line. But I have a question for you. Would I put a solid or dashed line through these points? Solid or dashed line? Well, since we have a strict inequality here, like I'm strictly less than, with the equal sign not being present, we would have a dashed line going through the x and y intercepts. So let's take a piece of graphing paper and then start to graph this thing here. So I'm going to plot my x-intercept, which is 3, 0, and my y-intercept, which is 0, 4. I'm going to put a dashed line through these points. And all we have to do now is just determine whether we shade the plane below and to the left down here or above and to the right. And the only way to determine that is to choose a convenient test point and see if it's a solution to our inequality. Is 0, 0 available? And the answer is yes, we can choose 0, 0. So what I'm going to do is I'm going to test 0, 0 in my inequality. And my inequality is what? 4x plus 3y is less than 12. That means I replace x with 0, y with 0, and we verify. Is 4 times 0 plus 3 times 0 less than 12? Is 0 less than 12? That's true. And so therefore, we've discovered that 0, 0 is a solution to the inequality 4x plus 3y less than 12. So we shade the plane that contains 0, 0, since it's a solution. So what plane contains 0, 0? Well, it's not going to be the plane above and to the right. It's got to be the plane below and to the left. So this would be the graph of the solution set to that inequality. Any ordered pair or point that lies in this shaded region, and there's an infinite number of them, would be a solution to that inequality. And we're done. We have graphed the solution set of 4x plus 3y is less than 12. What does the dashed line mean? The dashed line means that any point that sits on this line would not be a solution to the inequality, would not be a solution. Now, if this inequality had the equal sign here, less than or equal to 12, then we would have a solid line, which would indicate any point on the line would be a solution to our inequality. But since we have strictly less than 12, we have a dashed line. Any questions how we're graphing the solution set of a linear inequality in two variables, x and y? First, always graph the equation, then determine on what side of the line you shade by testing out a convenient test point. All right, I would like to do like a special case here, like number 14, while x is less than 5. How would we graph the solution set of x is less than 5? Well, to graph all ordered pair solutions that are less than such that x is less than 5. First, we have to graph the associated equation. So we got to graph x equals 5. Ladies and gentlemen, the graph of x equals 5 is going to be a what? A vertical line. And this vertical line is going to go through the x-axis at 5. Would I use a dashed or solid vertical line? Since I have the strict inequality of less than, where the equal sign is not part of the inequality, I will have a what? A dashed line. That's going to be a dashed line. So we take a piece of graphing paper here, and we're going to graph x equals 5, and the graph of x equals 5 is going to be a vertical line that goes through the x-axis at 5. 1, 2, 3, 4, 5, right here. So it's a vertical line going through the x-axis right here at 5. Would that be a solid or a dashed line? Oops. I think it was supposed to be a dashed line. So I got to take my white out and make it a dashed line. This should not be a problem. You agree, ladies and gentlemen? I now have a dashed line. Now, do I shade to the left or shade to the right? Do I shade the plane to the left or to the right, which will indicate my ordered pair solutions to this inequality? Well, choose a convenient test point. Let's test out the origin. Test out 0, 0 in the inequality x less than 5. To do that, we replace x with the x coordinate, which is 0. Is 0 less than 5? Is that true or false? It's true. And so therefore 0, 0 is a solution for the inequality x less than 5. So being the case, since it's a solution, we shade the plane that contains 0, 0, which means we have to shade not to the right, but the plane that contains 0, 0, which we found was a solution or an inequality, we shade to the left. And ladies and gentlemen, you are looking at the graph of all ordered pairs that satisfy the inequality x is less than 5. Any point that lies to the left of this vertical dashed line is a solution to this inequality. Any questions how we did that problem? All right, so that's the case of a vertical line. How about a horizontal line case in here? Did anybody see a horizontal line case in here? Oh, look at number 16. How would we graph the solution set of this inequality? Well, so how do we denote all the ordered pair solutions to this inequality, y less than or equal to -4? Well, first of all, we got to graph the associated equation. So we got to graph y is equal to -4, which is going to be a horizontal line. And this horizontal line is going to go through the y-axis at -4. Would I put a dashed or solid line? It's going to be a solid line now. Solid line, since we have the equal sign as part of our inequality. So as I would take a piece of graphing paper here, and we put a horizontal line through y equals -4. 1, 2, 3, 4, right here. And it will be a solid line. Here we go. Here's a graph of y equals -4. Now we need to indicate whether we shade the plane above or shade the plane below to give us all the ordered pair solutions to this inequality. To determine that, we choose a convenient test point. And the one I've always been using has been the origin. The only time you cannot use 0, 0 as a test point is if your line ever goes through 0, 0. Then you'd have to choose some other point. But 0, 0 is available. So we're going to test out 0, 0 in the inequality. And the inequality is y less than or equal to -4. To do that, I replace the y variable with the y coordinate of 0. So is 0 less than or equal to -4? Is that true or false? This is false. So 0, 0 is not a solution for the inequality for the inequality y less than or equal to -4. Hence, we got to shade the plane that does not contain 0, 0. That means we shade the plane below the solid horizontal line. And you are looking at the graph of all ordered pair solutions of y less than or equal to -4. That's the shaded solution set to that inequality. All right, ladies and gentlemen, I think I've worn out my welcome here today. So I've gone over sections 11.4, 11.5, 11.6. And I'll tell you what, maybe I'll just do, maybe do one with a fraction in here. We'll call it quits here. We'll do one more here. Number 23, what the heck, we'll do that one. Now notice this, this linear inequality in x and y has y on one side. And that being the case, as I'm going to graph the associated equation, y is equal to -1/2 x plus 2 should be pretty simple. Because this equation is in slope-intercept form. And therefore, the y-intercept of this line is +2. So the line has to go through the y-axis at 2. And the slope has to be -1/2. So the slope has to be -1/2 or 1/-2, however you want to look at it. So to plot any other point on this line, I could go from my y-intercept of 2, I could go down 1 to the right 2. So down 1 to the right 2, 1, 2. Well, I could have went up 1 to the left 2, up 1 to the left 2, up 1 to the left 2, or down 1 to the right 2. It's up to you. All right. At any rate, we have y is, what was my inequality? Y was less than or equal to, okay. So y is less than or equal to -1/2 x plus 2. And since we have the equal sign as part of an inequality, we're going to put a solid line through these points here to graph the boundary in the plane. Now I just have to determine what plane I shade, whether I shade the plane below and to the left or above and to the right to represent solutions to this inequality. To determine that, I'm going to choose a convenient test point. I'm going to try out 0, 0. In the inequality. That means I replace the y variable with 0, replace the x variable with 0, and I verify, is this true or false? So is 0 less than or equal to -1/2 times 0 plus 2, which is 2, because that's 0. Is 0 less than or equal to 2? The answer is that's true. So therefore, we have to shade the plane that contains 0, 0, since we found 0, 0 is a solution to our inequality. Well, that's going to be the plane below and to the left. And you're looking at the graph of the solution set of all ordered pair solutions to the inequality y less than or equal to -1/2 x plus 2. Any point that lies on this line or lies in this shaded region would be a solution to this inequality. And we're done. All right, so that wraps everything up. So I've done sections 11.4, 11.5, 11.6. And the only thing that we got left here is just some sections in chapter 12. And I will eventually get the quiz number 7 out to you guys, and also the final exam, which will be early next week. We're wrapping it up on next Tuesday's our last session, virtual session. All righty. Any questions? Any questions? All right. If there are no other questions, then I will let you go, ladies and gentlemen. You have a great day, and hopefully I'll see you on Thursday. Take care.